Today we're going to look at function notation. But before we even do that, let's take a look at this first problem here. Y equals 2x squared minus 8. Directions say find y when x equals 3. Simple enough. I need to take that 3, plug it in, substitute for x. So I'm going to take that, put it right there. So I get an answer of, or start the problem as y equals 2 times 3 squared minus 8. Order of operations here. Take care of exponent. 3 squared gives us 9. 18, and then 10. So y equals 10. Now, I might even ask, can you write that as a coordinate? Well, sure. What number did we plug in first? First, we inputted a 3, then we outputted and came up with an answer of 10. So we could rewrite that as a coordinate if we wanted to. So directions. Find y when x equals 3, plug it in, solve away. Okay, function notation. Function notation is this thing. We read that as f of x, f parenthesis f of x. So f of x and y are essentially the same thing. Now, this thing right here is read f of 3. This essentially is this. So all you need to do is say find y when x equals 3. So this 3 replaces that x. I want to replace every single x with 3, so that is also going to be a 3. So let's rewrite. 2, 3 squared minus 8. Now, isn't this the same thing that we have here? Let's just solve it. Let's simplify this whole right side. Exponents first, then multiplication. So we're going to say 9. You get 18. And then we get 10. So we then close it out and we look at this. So on that first one, we wrote a coordinate, 3, 10. Essentially what I have here is the same thing. What did I input? I inputted a 3. I came up with an answer of 10. So if I wanted to write that as a coordinate, what number do we input into the x? 3. What did we get out as a y? We got the 10. Great. We don't really need to go this far. It's good to understand it. This is what my answer is going to look like here. I plug in a 3, I get a 10. Can I do that now, but instead of having just a number, what if there's a number and a variable? What if there's an expression here? Well, let's do the same thing. Find y when x is 4a. Basically, I'm taking this 4a and inputting it everywhere I see an x. So I'm going to say 2 instead of x. I'm going to say 4a exponent minus 8. Still follow order of operations. This 2 needs to go to both of those. So we're going to say 4 squared, which is 16, a squared, which is a squared, all that, now times 2 minus 8. Now we can do multiplication. 2 times 16, 32. Bring that a squared for the ride, and bring down that 8. Now, I cannot combine these two things because we've got something called, we no longer have like terms. That's actually going to be the answer. So we're going to bring down what we plugged in. F of 4a equals 32a squared minus 8. Again, can't combine these, not like terms. We bring down what we put in. And that is using function notation.